Alright, so what we're going to do is go through the problems on the final review number 3. And like the other two, I'll try to go through these pretty quickly, so don't be afraid to reverse and fast forward. Alright, so if we look at this problem, we have 3 moles of copper, so I'm going to write 3 moles there, and 5.5 moles of silver, silver nitrate. And they react by a single replacement reaction, etc., etc. Which one is the limiting reagent? Alright, so you know this is a limiting reagent problem because each reactant has a value. So as you know, there's a few ways to figure out the limiting reagent. So what I'm going to do is, since we have to find the mass in grams of each product, what I'm going to do is take each reactant, so I'll start with 3 moles of copper, and I'm going to calculate how much silver is produced by each, and then the one that produces the smaller amount will be the limiting reagent. So let's do the dimensional analysis. If we want to go from copper to silver, we're going to do the mole ratio. So we have 1 mole of copper for every 2 moles of silver, and I'm getting those values from the balanced equation. And then what we're going to do is convert 1 mole of silver to grams of silver. So that's 108 grams, and again, that's the molar mass from the periodic table. So let me do the math here real quick. I did not do this one already. So 3 times 6 times 108. That's not right. 3 times 2 times 108. So that's going to give us 648 grams of silver. So then what we're going to do is take the other reactant and do the same thing. We're going to calculate how many grams of silver are produced. So we'll start with 5.5 moles silver nitrate. And again, we'll do the mole ratio from silver nitrate, AgNO3, to our silver. Whoops, 2 moles of silver. And we'll convert that to grams, so 1 mole of silver. Again, 108 grams, and let's do the math there. 5.5 times 2 divided by 2, and we get 594 grams of silver produced. So this is the smaller amount, which means the silver nitrate is going to be the limiting reagent. So what we're going to do then is use that limiting reagent to calculate everything else. So since we already found the grams of silver, what we're going to do now is find the grams of the copper nitrate. So we'll start with 5.5 moles silver nitrate. Again, do the mole ratio. So there are 2 moles silver nitrate for every 1 mole of copper 2 nitrate. And then we'll go 1 mole copper 2 nitrate, and what is the molar mass of that? 188 grams. And again, that's the copper 2 nitrate. So then when we do the math there, we should get 517 grams of the copper nitrate. And again, we've already found the grams of silver, so we have both of our products. Well, the next thing we want to do is figure out how much of the excess reactant is left over. So we're going to take our moles of silver nitrate and calculate how much copper actually reacted. So again, start with your moles silver nitrate. It is a 2-to-1 ratio, so 2 moles silver nitrate for every 1 mole of copper, and that is going to give you 2.75 moles of copper, and that's the actual amount of copper that reacted. So then what we need to do is take the initial amount, which is 3, subtract out how much actually reacted, and then we have 2.5 moles in excess. Now you could do change that to grams, but it doesn't say grams, so we're just going to leave it in moles. Alright, let's move on to the next one. So let's get a new screen. Let's clear that, and let's get a pen. Alright, so the next one is a basic stoichiometry problem. We have our reaction. we're looking for grams of NaOH, and we are starting with 25 grams of sodium. So we are going from here to here. Now this is your basic stoichiometry problem. So start with the given, 25 grams sodium. You know what I'm going to say, what goes in the denominator. Always go grams to moles. 23 grams from the periodic table. Moles of sodium in the denominator. Moles of what we're trying to find in the numerator, and it's a 2 to 2 ratio. So we have that. And then we want to convert to grams. So we're going to put moles in the denominator. Add up the molar mass, and I believe that is 40 grams per mole. 23 plus 16 plus 1. Yes. Yes. All right. So anyway, do the math there, and you wind up with 43.5 grams of sodium hydroxide. All right. So let's move on. Let me get a new screen. Let me clear. Whoops. Clear. Let me get the pen back.